Hey everybody, our next lesson is going to be on constructions, and we're going to use two different kinds of compasses. First one is called a bullseye compass. Bullseye compass is pretty cool. It's got this adjustable slide and the pencil holes that you can use, and this part here that I call the nose, because it has this little divot here that you can center over a point, press and use this as a center point for it to spin. The other kind of compass we use is more of a traditional kind of compass, where we have a point and this whatever kind of holder for a pencil, and then we'll call this the arc, but that helps you know how far open and closed your compass is. Alright, so why do we do constructions? So when we read this, your goal is going to be to create a segment that is congruent to segment AB here, which means we want the distance from A to B to be the same. Here's the story about this. If I were to get a ruler, any kind of ruler, measuring ends up being a little tricky. You can see this is an old ruler where this has broken off, so I got to make sure that I'm clear about how long the segment is, whether I'm using inches or centimeters. Maybe this ruler might help a little bit. This is a little confusing because my symbols stop after a while. Same with on this edge. So using a ruler to remember that distance or that length might not be as easy. What the compass allows us to do is to put the nose over top of the one point, slide and lock in the measure of another, and that distance is now locked in. So I know the distance from my nose to where my pencil goes in. Once I lock it, that distance is absolute, and I can transfer that distance to another place. So when we talk about measuring and redrawing not being the best option, I'm at the mercy of my measuring tool, and this compass allows me to lock in that distance, and it will always be. Same with this compass. If I mark here this point and I open this up, I can lock in this distance and know that the space from the point to the pencil is always going to be absolute, and I can transfer that distance somewhere else. All right, task one. When I'm copying a segment, my first step is going to be to draw, to use a straight edge and draw a line longer than the segment that I'm copying. So I'm going to go ahead and take my ruler, and I'm going to draw a line segment, and I know it's longer than that one that I'm tracing. So here's my new segment. When I'm marking my new points, I can either name it by new points, or I can use the prime system, where I can say this is A prime, and that's going to be this point that corresponds to that point there. All right, I'm going to take my nose, I'm going to put it on A, I'm going to take my slider, and I'm going to lock it in over top of the end of point, the segment where B is. I'm going to draw an arc to show that I measured that part. When I come down here, I'm going to put my nose on that point, and I'm going to draw the same arc. That guarantees that this distance from A to B, I just transferred down here to A prime to B prime. The reason why we made this segment longer was so that I can guarantee to cut this distance off. So I know that the distance from A to B is equal to X. I transferred that distance down here, so I know that X is equal to the distance from A prime to B prime. So then now I know that since they are the same, I know the distance from A to B is equal to the distance from A prime to B prime. There's my new segment. All right. Copying an angle. So when I want to look at copying an angle, my goal is to make two angles with the same amount of space in the interior. So that mouth of the angle has to be. Now what's interesting is our distance is different between the sides of the angle at different parts of the angle. So I need to make sure that I draw something that helps me know where I'm measuring the sides of or the opening of the mouth, the distance between the sides of the angle. All right, step 1, draw a base of a new angle. So in order to do this, I'm just going to draw a straight line, and this is going to be the base of this new angle. I'm going to have my vertex here and some point here. All right, so now what I want to do here is I want to draw what's called a working arc. And the working arc helps define where in this angle I'm drawing. So I'm going to put my nose on my vertex, and I'm going to open up, I'm going to slide my slide any arbitrary distance. And I'll do this one in pen so you can see the difference between my pencil markings where I was measuring. So this here is what I'm going to call my working arc. And that just means that's the place where I have opened up the angle, and I'm going to measure this distance. All right. Once I have my working arc here, I'm going to take that same distance and I'm going to mark it and draw that working arc on my new angle side. So I've got this distance here is guaranteed to equal this distance here. Now I need to know where to draw this other side of my angle so that the degrees, the space between the sides of my angle, is the same. So what I'm going to do is I'm going to take my compass and I'm actually going to measure how far open the mouth is at the place of my working arc. So I'm going to put my nose here. I'm going to, you can see where I have measured that. I'm going to put my nose on my new angle, and I'm going to mark where that distance occurred. Now I know the space between here and here is the same as the space between here and here. My working arc helps define where I measure the size of that opening. Now I connect my vertex through my point of intersection, and I know that this degree measure is now the same as this degree measure at that point. I drew a new base of the angle. I drew a working arc. I drew my same working arc. I measured the mouth of the angle. This right here represents our mouth of the angle, how far open it is. And I copied that distance down here. Here's that mark I drew. And then I was able to connect the vertex to the arc intersection. And I have a new angle. So I know that the measure of angle CDE is going to be equal to the measure of my new angle C prime, D prime, E prime. Copying an angle. Okay, so for this next construction, we're going to be bisecting a segment, and for this one, I'll use our traditional compass. So, oops, this should say point. Our point should be on to endpoint C. And what I'm going to do is I'm going to slide my opening so that it's greater than half of the segment, and I'm going to lock in the measure, and then I'm going to draw an arc above and an arc below. my line segment. I'm going to take that same distance without moving it, and I'm going to put my point on my other end point, and I'm going to draw an arc above, and I'm going to draw an arc below. What I can do now is I can connect this point of intersection and this point of intersection, and what that guarantees is that this point here will then bisect this line segment CD. Now remember, you can only bisect a segment. You cannot bisect a ray, you cannot bisect a line. Okay, let's go over what I did. I put my nose or my point on endpoint C, and I opened up the distance of my compass greater than halfway, and then I locked in that measure, and I drew that arc above and below the line. I put my nose or endpoint on the other end of the line segment, and I drew my arc above and I drew my arc below the line, and I can connect them. That guarantees that this segment is bisected. These two segments are going to have the same length. That means that this is also the midpoint. So we'll talk about why this works after we start exploring a little bit of triangles and polygons. You're going to like it. All right, when we draw a segment bisector, we're drawing a line connecting those intersections, and then here's our midpoint. All right, a little reflection question for you to sit and think about. Is this bisector perpendicular to CD? The answer is yes, it is, but the question is, how can you be sure of your answer? And can you bisect a segment and not have the perpendicular be bisected, but the bisector be perpendicular? So I'm going to let you play around with that and see what you think, and we'll go over that when we talk to each other in class. All right, last construction here, bisecting an angle. So I want to cut the space in between these two sides of the angles in half. We'll go ahead and, again, we'll use our traditional compass for this one. We're going to put the nose on the angle, and we're going to go ahead and draw, we're going to lock in any arbitrary distance, and we're going to draw a working arc. So here comes our working arc. And the reason we need a working arc is because we need a place from which to measure. So this point here becomes super important, and this point here becomes super important. There's our working arc. Now I'm going to take my nose or my point, and I'm going to put it on the intersection of that arc, and without changing the distance, I'm going to draw an arc. Oh, this keeps slipping on me. Hold on. I'm going to draw an arc out here in no man's land. I'll try to get this to lock in a little better. Mine's slippy. So I'll lock in the distance, and I'm going to draw an arc out here in no man's land. And I'm going to keep that same distance the same, and I'm going to draw an arc out here in no man's land. Okay. So what I have here is this point of intersection here, and I'm going to take my straight edge, and I'm going to connect my vertex to my point of intersection, and I'm going to recognize that what I've done now is I've cut this space equally in half, and I have two angles that are now congruent to each other. I've bisected that angle. I put my point on the vertex. I drew my working arc, and remember, your working arc is going to be this thing here, and the purpose of needing that is so that I have these two intersections from which to draw these arcs. Draw an arc in the interior of the angle, I put it on my other arc and angle intersection, and then I connected my vertex to my interior arc intersection. All right, so you have a couple of reflection segments. Think about the segment and angle constructions. How do they guarantee congruence? That's an interesting question I want you to think about. Think about the segment and angle bisectors. How can you be sure that the pieces, both the segments and the space in between the angles, are congruent? So we'll talk about that more in class. So you have a practice coming up, and I want you to work on doing that. Good job. Remember to ask questions in class.